This is 9.5, irrational numbers. An irrational number is a number that is not rational. It cannot be written as a fraction where a is over b, and where a and b are integers, which means they're whole numbers, and b is not 0, because we cannot divide by 0 in a fraction. The square root of any whole number that is not a perfect square is irrational. Same thing for cube roots. If it's not a perfect cube, the cube of that number is irrational. So 7 is not a perfect square, and so its square root continues on forever and ever, does not repeat, does not end. Every number can be written as a decimal, and that number will either repeat, end, or it will be irrational and continue on forever. A real number, real numbers are the set of rational and irrational numbers. So here we have a diagram, and it shows all the different types of numbers. In the center we have natural numbers. That's like counting on your fingers, 1, 2, 3, 4, so on. Then we have whole numbers, which are all the natural numbers plus 0. Next we have integers, which are all the whole numbers and all the negatives. So these are like the whole numbers that you see on a number line. Then we have rational numbers, and that's all the integers, and then numbers that can be written as fractions, negative fractions, decimals, repeating decimals. Those are all rational. Then we have irrational numbers, and that would be like the cube root of 7, pi, the number e, square root of 2, negative square root of 3, things like that. So we're going to classify each number into subsets and why it fits there. So if it fits inside the natural numbers, it also fits in all the layers further out from it. So a natural number is a whole number, which is an integer, which is a rational number. Alright, so we have square root of 10, and this is irrational because it's not a perfect square. Negative 0.3 repeating is rational because it is a repeating decimal, and that would be out here. Negative square root 25 is an integer, and it is rational because the negative square root of 25 is negative 5. So we'd find where does negative 5 fit? Here. To approximate an irrational number, we're going to make a table and keep narrowing in until we get something pretty close. So we're going to approximate the square root of 90. So I'm thinking, can I find a perfect square that is close to 90? And if I think, well, there's 9, because 9 times 9 is 81, I can get a little bit closer than that. So perfect square close to it is 10 to get 100. But 90 is somewhere in between those. It's a little bit closer to 9 squared than it is to 10 squared, because this is only a difference of 9 and this is a difference of 10. So I know it's going to be maybe like 9.3, 9.4, something like that. So if I try 9.3 squared, I get 86.49. If I try 9.4 squared, 88.36. And if I do 9.5 squared, I get 90.25. This is pretty close. It's closer than 88. So we're going to say that the square root of 90 is about 9.5. To approximate a square root of 10, I try and think of two perfect squares that are close, like the ones on either side, and that would be 9 and 16. And square root of 10 is a whole lot closer to square root of 9 than it is to the square root of 16. So I'm going to try things that are closer, like 3.3. and 3.2, and I see that 3.1 and 3.2 are the closest. So I find out how far away are they from 10. This is 0.24 and this one is 0.39 away. So 3.2 is the closest we can get to the square root of 10. We can get closer if we continue into the hundredths place or maybe even the thousandths, but for us the tenths place is going to be closest now. So now we're going to compare with greater than, less than, or equal to. I have square root of 30 and cube root of 65. Well, I know square root of 30 is going to be a little bit bigger than 5 because this is bigger than 25, and 25 is perfect square. And I have the cube root of 65, and the closest cube root is cube root of 64, which is 4, so it's going to be a little bit more than 4. So just by knowing those, I can place them where they're going to be and know that square root of 30 is going to be larger. So we're going to approximate the distance between -3, 1, and 2, -3. And here I'm going to set up a right triangle so I can use the Pythagorean theorem. And then in plugging in those distances of -4 and 5, I'm going to get 16 plus 25 is c squared, square root each side. And the square root of 41 I find is about 6.4.